Hello everyone. In this video we will see definition of conjugate of complex number. If z is equals to x plus iy, then conjugate of a complex number is denoted by z bar, when the value of z bar is equals to x minus iy. Remember one thing, we are just changing the sign of imaginary part. So let us see some examples related to conjugate of complex numbers. So suppose z is 2 minus I. Let us try to find out a z bar of this. So for 2 minus I, conjugate of 2 minus I will be 2 plus I. 3 plus 2i, conjugate of 3 plus 2i is 3 minus 2i. Just change the sign of imaginary part. Conjugate of minus 4 minus 2i is minus 4 plus 2i. Conjugate of minus 1 plus 3i is minus 1 minus 3i. Now what is conjugate of 2? As there is no imaginary part, basically 2 is at such a real number, but any real number we can always represent in the form of complex. We can write 2 as 2 plus I times 0. Now what is the conjugate of 2 plus I times 0? It will be 2 minus I times 0. So the final answer of this is 2. So for the real number 2, the conjugate of it is nothing but 2. So for the real number, conjugate of the number is same as the original number. Now for minus 2i, the conjugate of minus 2i will be plus 2i. Just change the sign of the imaginary part. Here the real part is 0, but it doesn't matter because we just need to change the sign of imaginary part. So the conjugate of minus 2i is plus 2i. Let us see what is the conjugate of 0. Now conjugate of 0 will turn out to be 0, obviously. Let us see some properties of conjugate now. Now what will be z bar bar? That is conjugate of z, and then again take the conjugate of it. So this is turn out to be again z. It's quite obvious. Suppose if I have z as x plus iy, conjugate of x plus iy is nothing but x minus iy. If I take again conjugate of this, it is x plus iy. So if I take conjugate of x plus iy twice, I'll get x plus iy back. So clearly conjugate of z bar will be z. Now z plus z bar. We know that z is x plus iy. Clearly z bar will be x minus iy. So if I add this two, I'll get the final answer as, here clearly iy get cancelled and we will get the answer as 2x. You can also say that this is nothing but 2 times real part of z. So this will actually give you the answer of real part of z. So real part of z is nothing but z plus z bar divided by 2. So this implies real part of z is nothing but z plus z bar divided by 2. Now let us try to find out z minus z bar. Z minus z bar is x plus iy minus into the bracket x minus iy. Now this is equal to x plus iy minus x plus iy. So here x get cancelled out and you will get 2 times iy. Now 2 times iy is nothing but 2i, and y is basically imaginary part of z. So this is imaginary part of z. So this clearly imply imaginary part of z is nothing but z minus z bar divided by 2. Now let us try to find out z into z bar. It's quite easy to find out. Z is x plus iy, z bar is x minus iy. So if I multiply this, I'll get, this is like a plus b, a minus b. The formula is a square minus b square. So it will be x square minus I square y square. I square is minus 1, so this is nothing but x square plus y square. Now for any real number z, so suppose z is a real number, so this implies z is equal to z bar. As we have seen in the earlier slide, the conjugate of 2 is nothing but 2 because 2 is a real number. Here z1 plus z2 the whole bar. Now I'll just directly write down this property. It is z1 bar plus z2 bar. So you can distribute conjugate on addition. Now let us see what will be Z1 into Z2 bar. Clearly Z1 into Z2 bar is Z1 bar into Z2 bar. Again, the value of Z1 by Z2 the whole bar is Z1 bar divided by Z2 bar. You can also check these last three properties with the example. Thank you.